coulomb. If 2 joules of work is done in transferring 2 coulombs, এখানে দেখো ওই কোয়েশ্চেনটা তুমি ট্রাই করো, ট্রাই করে এ দেখো এই ছবিটা খাতায় আঁকো, ওই কোয়েশ্চেনটাকে ট্রাই করো, তারপরে এই ছবিটা এঁকে আমাকে খাতা করো। Okay. In today's meeting of class 12 physics chemistry, we are going to do one topic known as packing efficiency. So in previous meetings, I have told you about primitive, BCC, FCC. Now in an FCC, there is suppose one particle is at this corner, one particle is at this corner. Okay, at the two corners there are two particles, and in between you can see that there is another particle over here, right? So at the two corners there are two particles, one over here, and in between there is another particle. So the distance from here to here, this entire distance, it will be r plus 2r, so 4r, and each side of the cube is a, so 4r will be a root 2, so a will be 2r root 2. So each side of the cube will be 2 root 2 times the radius of the constituent particle. So this is like a formula, you have to remember it like a formula. Now what is packing efficiency? Packing efficiency means the total volume of all the constituent particles as a percentage of the volume of the cube. So packing efficiency literally means the total volume of all these constituent particles, so it is FCC, so there will be 4 particles in a unit cell. So the total volume will be 4 into 4/3 pi r cube divided by the volume of the whole cube is 2r root 2 whole cube into 100. So that is coming to 74%. So for FCC, the things you have to remember, one is A is 2r root 2, the other is packing efficiency 74%. Next we come to BCC. So if you have a constituent particle at this corner, a constituent particle at the diagonally opposite corner, and along the body diagonal there is another particle. So therefore the body diagonal is A root 3. So A root 3 will be equal to 4r. So r will be equal to A root 3 by 4. This body diagonal is A root 3, that is 4r, so r is A root 3 by 4. So this is, or you can say that A is 4r by root 3. So this is number 1. The second thing is the packing efficiency. So in BCC, you know that there are number of particles per unit cell is 2. So 2 into 4/3 pi r cube into 100 divided by 4r by root 3 whole cube. So packing efficiency will be 2 into 4/3 pi r cube into 100 by 4r by root 3 whole cube. So that is coming to 68%. So in BCC, A is 4r by root 3 and packing efficiency is 68%. Then we come to primitive. Okay, the next one is primitive. Let's come to primitive. So in primitive you have 2 particles touching each other like this. So 4/3 pi r cube, there is only one particle per cell, so 4/3 pi r cube divided by the volume. Okay, now this is r, so A will be 2r. Okay, so A will be 2r, and 4/3 pi r cube is, because there is only one particle per unit cell, so 4/3 pi r cube by the volume of the cube is 8r cube into 100. So if you calculate this, it is coming to 52.4%, right? So you will notice that the packing efficiency of FCC is 74%, the packing efficiency of BCC is 68%, and primitive is 52.4%. So the packing efficiency of FCC appears to be the highest. Okay, it is 74% and that is the highest. So packing efficiency is the fact that according to the scientists, the particles will pack themselves as closely as possible. That is why we use the word packing efficiently. It has to be an efficient packing. The particles have to pack themselves as efficiently as possible. So the most efficient is FCC and the least efficient is primitive. So this is the topic for today, packing efficiency. And so I'll give you the homework now. Okay, the first homework question is that in cesium chloride crystal, the Cs plus ion is at the center and chloride ion is at each corner, and radius of cesium cation is 169 picometer, radius of chloride anion is 181 picometer. So what is the edge length of the cell? What is the edge length of the unit cell? Options are 350, 175, 303 and 404. Okay, the second homework question is that there is a cell in which capital M is at the center of the top two and bottom two edges and at the center of the body. Capital M, it is at the center of this edge, bottom edge, this edge and the body center. And capital X is at every face center and at every corner. So what is the empirical formula of the compound represented by this unit cell? Options are Mx, Mx2, M2x and M5x14. So these are the four options. And question number 3, you are given that the radius size of the cation, the radius of the cation is 1 picometer, the anion X is 1 picometer, Y is 2 picometer. So the question is that what is the ratio of the volume of the cell formed by A and X and the ratio of the volume of the cell formed by A and Y, and options are 0.057, 1, 0.217 and 17.54. So these are the homework questions. 3 questions are there. You have to do it by 9 p.m. tomorrow. I'll end the meeting. Bye all of you.